This is not going well. Making stuff is fun, man. You should do it. Super easy, and you never mess things up. We sell a lot of Kappas because they're awesome. They're incredibly tedious to assemble. So the point in making this whole machine over here was to be able to put Kappas together faster. So this is the female part of the Kappa where we have to insert the spring. Now the tricky thing here is the spring is much larger than the hole, and when we install it, we have to compress that spring, drop it down into the bore, and then let it pop open. There are a couple ways to do it. The hard way, basically you push the spring in kind of on an angle like that, and then you take a pick and you go in and lift that bottom side of the spring up into the groove and then push it in. It's not terribly hard, but you can see I had to fuss with it a lot. One of the first tools I made was this little fella here, which is just a little trumpet-shaped dingus. And one thing that's cool about this is you can just pick up the spring, then you push that into the bottom, but then you still have to go through this relatively complicated process of tucking the spring in, and then you just pull this back out. So the next thing I came up with was this pusher system. And now normally when you're installing these kinds of springs on an industrial scale or O-rings or something like that, you may use one of these tapered insertion tools. You can also use this method for installing like split rings and wave springs and stuff like that. This is the first pusher that I made, which is just a little piece of machined Delrin. I slotted these slots just on a bandsaw by hand. So a few weeks ago, I printed my first one on the Markforged. The spring gets held in there the same way as on the 3D printed part, but this one's aluminum. I'm not sure the 3D printed part's gonna hold up long term, but so you slide that sleeve over, take the pusher, and you just push that down. Wow, I don't know why that's not working. So this is the old janky one. It was handmade. Is that all the way in? That's the other thing. This one, it's hard to tell. Yeah, again, that, obviously did not work that great either. And apparently that's why no one wanted to use it. So this is the base for my Kappa QR spring insertion tool that I've been working on. I made 3 holes in here to mount it to something. I didn't really think about what I was actually going to mount it to, but since I never throw anything out, I found something. This is a printing sample from some company apparently called Ferrari Color. This is going to screw down onto here. Well, however, I need to make some holes. Sort of a rookie fabrication mistake. I made these holes exactly to size. When I put these screws in, they fit tight, which means the holes I make in this piece have to be exact, otherwise I'm not going to be able to push the screws through. Instead of marking these holes out, I'm actually going to try to laser cut them. I expect this is going to go badly. This is a very thick piece to laser cut. I'm definitely going to have to do multiple passes, but we are going to press ahead anyway. You smarty pantses out there are going to wonder why I don't just make the holes in this piece oversized so that my screws are going to line up. And the reason is I would like to use countersunk screws with the 82-degree taper on the head, countersink the backside so those screws will go in flush, so this is going to sit down flat. So because those have that angled hole, that screw is always going to want to center up on that hole. If they're slightly off, that means the screw is going to go in sideways and it's going to stick out. So we're just going to try to fudge it and see how far we can get before we ruin this whole thing. All right, I've got my trusty hammer and screwdriver. We'll see what happens. Oh, darn it. Well, I made a mess. Well, that is working much worse than I was hoping for. Power tool time. I'm just gonna run this through. I expect these holes are kind of jacked up already. Everything could always be worse. The main problem is, I don't have my 3/8 inch screws yet. I forgot to order those. Maybe I will make an effort at trying to countersink the back of this. Alright, so I have some parts fresh off the printer. Here is the base that we were talking about mounting to that bamboo part. And basically, these two things are side supports. And there are some screws here, so this will sit down like so. This is all going to attach together. And then these 3 bolts on the bottom here are going to go in the 3 holes in the side of this thing. Something like that. What's this going to hold? The regulator, air pressure regulator for the pneumatic insertion part. So as you can see, these holes were not modified in any way after printing. They fit so close. I mean, it's tight enough to where it won't drop through cleanly, yet I can push it in. They were actually a little bit tight. And there are going to be some very minor printing artifacts inside this hole, but basically you push the screw through and it breaks those off. All right, so this is the front. The Kappa's there's some more parts that go onto this. Are you kidding me? The only way to get this better would be machining it. Okay, so I've not put screws through these holes yet, so they're going to be quite tight. So I'm just going to double check and just at least push them through one time, and that does break off some tiny imperfections. But, this is going to go here. Oh, that's pretty tight. All right, and this is going to go in here. This both provides support and mounting for the air regulator. Let me go get the air cylinder, I'll be right back. So here's my Bimba air cylinder. Pressurized extension, spring retract. So this cylinder is basically gonna slide in here. And then it's gonna get clamped down at whatever the appropriate height is. So it's adjustable because the height will have to be very exact. So the only way to get it exact is to make this adjustable. But it should be in this range somewhere. This is shaping up. There is some chance that this thing is gonna work. Check it out. Our most recent 3D printed part. Will it fit? Oh. Yeah, that pretty much couldn't be better. So this goes in here, maybe. Oh, that is so money. And this bad boy goes in here upside down. Ta-da! 2 more parts to print. There's a little carrier that slips down over the Kappa to hold the spring, and then the pusher that attaches to the shaft of the pneumatic cylinder. It pushes the spring down. So far, we're looking pretty good. So we got everything plumbed up. Little regulator installed in the back. This is an exhaust muffler because when you release the pressure, that air shoots out the back. I'm less concerned with the sound than a huge jet of air blowing things around the work area. Let's plug this in and see what happens. Here we go. Oh yeah. That's pretty cool. So this little valve here is actually a speed control valve, which is why this cylinder rod isn't slamming down to the bottom. It's letting the air in slowly, and that's hopefully going to help us not break parts or pinch our fingers. All right, gang, so we have our last 2 3D printed parts. We're going to find out if this thing works or not. It works in theory, but everything works in theory. This is the pusher that's actually going to force the spring down and sort of do the bulk of the work. The end of this plunger is threaded, and this piece is gonna thread up onto there. I hope tapping it is the right move. It probably doesn't need to be tapped, but that's never stopped me before. So we just got a 1/2 inch 5C collet in the chuck here. Slide that in, give it a grip, and 1/4 28 cut tap. And we're just gonna kind of do this manual-escally. And now that we have the tap started, I know it's in there square, and we are just gonna finish this off. I can't really tell if that went all the way down there, but we're gonna assume it's good. How about that? I guess the first thing I'm gonna do here is go ahead and attach this thing to the base before I test it. So here's my janky piece of bamboo. I did randomly countersink these. Darn it, that's gonna have to go deeper. Oh, money. That's how the pros clean up. Good, good, good. Yeah, this has got to go on here. I did not test fit these bolts to see if they're actually going to pass through my holes or not, because they feel kind of tight. Oh yeah, well, it is right on. That is actually a tiny bit too tight to push through. Don't worry, I have tools. Alright, so this is just a 3/8 inch reamer. This is also probably a bad idea to do by hand, because you really want this to go in square. The fun thing about building stuff is there are just so many opportunities to screw it up. Pro tip too, when you're reaming or drilling plastic, you really don't want to go too fast because it's really easy to melt it. One more time. Come on now. There we go. Oh yeah, that totally worked. Let's button this thing up. Haha, look at that. It definitely looks like a thing. It could still 100% have been a waste of time. So let's get on with the rest of it. So this is basically a little tapered sleeve, so it starts big and it gets small. And as we use the pusher to push that spring down the taper, it compresses it. And then if we've done everything right, that spring should pop nicely into the hole. And then the actual Kappa just slides into the bottom of this sleeve. Before I put power to this thing, I should just try pushing one through by hand and make sure this part works, because if this doesn't work, the whole thing's kind of boned. So this is the one we've been using basically with this little manual plunger that I made. So I'm pretty confident the pusher or plunger is gonna work. But this is made of metal, and that's just a little bit more slippery for the springs. So we have these teeny tiny coil springs. These are actually made in straight coils and then cut and welded. The weld also has to be facing a specific direction, which is up out of the hole. Kappa goes into the sleeve, get our little spring oriented correctly, set that in there. That's gonna be a manual process. We're gonna have to set these things in here by hand. And then I'm gonna play the role of the pneumatic plunger, try to push it straight down. All right, so our next order of business is to get this little feller that we just tapped threaded on here, which is gonna be straightforward. Why do I say that? It's a little snugger. Nope, does not want to go on. It's also really wanting to cross thread. Nuts. It's because I don't want to mar the shaft, because that's riding on an O-ring inside there, but I do need to thread that all the way up. I'm gonna have to figure something out. Oh. Somebody majorly screwed me. I didn't really look at this tap carefully. It was in the 1/4 28 box. It is a 1/4 20 tap. So I'm gonna have to tap the wrong size threads into my part, which means I'm gonna have to rethink this again. Oh, I'm back. All right, so I did not film this, but I basically just did the same thing I did before. I chucked this up on the lathe and just ran a quarter 28 tap over the quarter 20 threads already cut, which is a horrible idea. You should never ever do that. Except in this case, this is the only part I've got at the moment, and I don't think it's really gonna matter as long as I can get this thing started. Yeah, see? When you have the right size threads, it makes threading things together a whole lot easier. I think it's gonna be fine. If it's not fine, I'll just print another one and tap it properly. Now, I need to set the stroke length, which means I'm probably gonna need to loosen up some of these screws and adjust this up and down until I get the right amount of distance. The trick is gonna be figuring out what that distance is without absolutely smashing this thing into my part. So that should be fun. I want these flats basically to travel past this face, maybe 100 thou. We'll loosen these front screws and see if we can't slide that cylinder up and down. Oh man, that's... that is well clamped. I guess I should undo more screws. Okay, there we go. If I pull this all the way down to the face, that will not quite be long enough. How am I going to move this down a precise amount? I'm going to use a Sharpie. Sometimes the inelegant solution is the best solution. I'm just going to draw a line. Alright, so if I push that down now, it's going to slam into the part. I'm going to need this thing on there. Really, the other question is if this is lined up well enough for that to enter. Again, I think I've modeled a chamfer on here, but it's kind of hard to know. Your chamfer doesn't always quite look right or come out right. So that tiny little chamfer, well, I made the existing chamfer bigger. That's hopefully going to help that. Oh yeah, that's fine. Okay. Air, are you as worried as I am? We're gonna put an empty Kappa in here. We are gonna take a spring, correctly oriented, slide that in there like so, and in theory, if I hit that switch, magic should happen. Are you ready? Fire in the hole! Oh, money. That was the first try. It wasn't totally smooth, but it worked. All right, next try. Got the Kappa, got a spring, set that in there. Fire in the hole! Okay, that did not push all the way. This thing is retracted the entire assembly. I think there are two ways to look at that. One is this didn't work and it got jammed. The other way to look at it is now I've extracted my part, and then that does come off fairly easily. I'm inclined to just let this go for now and see, because things are probably going to loosen up a little bit. I might see how this breaks in before making any major changes. It does seem like we need a touch more air pressure though. 90 pounds. Again, Kappa, spring and Zeke. Here we go. Oh, that was definitely more aggressive. So far, I am very pleased. You saw the tools I made before. I definitely think this is an improvement. I am floored that this thing has actually worked so far. It may stop working whenever you build a mechanical system. Sometimes it works for a while, and then sometimes it stops working just because things break in and move around. I am also incredibly pleased with the performance of the Markforged printer. Again, like, I only printed these parts one time. Normally when I 3D print parts, you have to do it 2, 3, 4, 5 times until you get it right, and you have to mess with the settings and the dimension stuff and stuff like that to get what you want. Just the time savings alone is a huge plus, because time is money, and we only have so much time, we only have so much money. Thanks for watching. We'll see you guys soon.